Good morning, boys and girls. We're going to continue in lesson 3 today and talk about the skeletal system. But instead of talking about the axial bones, which are the bones that are in the middle of your body, the support center of your body, we are going to be talking about the appendicular bones. Appendicular. That's 5 syllables. That's a great big long word. Um, let's review just a little bit before we move on. Do you recall using the word cells, tissues, and organs as we talk about our bodies? Cells are the building blocks of all tissues, and tissues are one kind of material in the body that make up organs, and organs have a job to do in your body. So does your human body system work independently? Does each one work independently, or are they interconnected? That's right, they are interconnected. Make sure that you remember complex machines have many different parts that have to work together. They are interconnected. So why are the skull, spine, and rib cage called axial bones? Do you remember the axis of the earth? The axial bones in the human body are bones that support the center of the body. And why are axial bones important? Because they protect the most important organs in the body. You remember, you start at the top with your skull, supports your brain and all of the senses that you have going on in there. The spinal cord is protected by the vertebrae that run down your back. And your ribs support your heart and lungs. Why is the skeletal system as a whole important to the human body? Well, the skeleton is a framework that keeps the body from toppling over. If you didn't have a skeleton, you wouldn't be able to stand or move. You would have no shape, and you wouldn't have any blood, because that's where you get your blood. So it gives you shape, it helps you move, it produces blood, keeps you upright. So today we're going to hear about different types of bones, and we're going to hear about joints. That's sort of a new thing. So listen carefully to learn about appendicular bones and joints. Here's our narrator, Ricardo. Hello again. Before we begin, I want to know who is able to correctly spell the big V word that we talked about the last time we met. Who would like to try to spell vertebra? Ooh, it's a really hard word, but we've really talked about it for 2 units now. So it's one of those really large vocabulary words that could be super impressive when you learn to spell it. Because if you learn to spell it in 3rd grade, you'll learn to spell it forever. It's V-E-R-T, verte, T-E, B-R-A-E, vertebra. V-E-R-T-E-B-R-A-E. Cool. Well, today we're going to talk about another big word called appendages. I was quite small the first time I ever heard that word. I used to cling to my mother's leg all the time, and I would often hear her say, "Ricardo is my little appendage." I never really knew what that meant. Do you know what it means? Well, now years later, it makes perfect sense to me, because an appendage is something that is attached to or hangs out from something larger. So when I was clinging to my mother's leg, she said I was hanging on to her. Today, you're going to learn about the other bones in your skeletal system, the bones in the legs and arms that hang from your axial skeleton. These bones in your appendages are called your appendicular bones because they hang on to the larger bones of the body. Let's try saying those words together. Appendicular bones. Say it again. Appendicular bones. Well, let's begin near the top of your skeleton with your arm bones. What are your arms attached to? What do they hang down from? Well, if you answered your shoulders, you are right. Your shoulders are made up of several different bones. Look at this picture to see how arm bones are connected to the axial skeleton. There are large, flat, triangular bones that you see in this picture, and they are called scapula or shoulder blades. They're sometimes referred to as wings because they stick out a little from your back. Now look at the long bones that connect your scapula to the top of your rib cage. They're called clavicles or collarbones. So this is your scapula, these triangle shaped. But then if you can see, it's sort of hard to see in this picture, you have a collarbone. If you are in the very front, right underneath your neck, there are some bones that sort of stick out. And those are called your collarbones because they're right up there near your collar. Or actually, maybe your shirt on your collar is called a collar because of your collarbones. Shirt collars cover your collarbones. Well, let's move down the body just a little bit to the base of your axial skeleton. Remember, we're looking inside. So here's your axial skeleton coming in, and here's the tailbone and the base of your axial skeleton that's in the middle of your body. How are your legs attached to your spine? Legs need a hanger. Their hanger is called the pelvis. It's a group of strong bones illustrated in this picture. Put your hands on your hips and see if you can feel the bones that stick out at your sides. These are your hip bones or pelvic bones. Your pelvic bones are large, bowl-shaped bones that protect your bladder and your intestines, very important organs to help your body function properly. Your pelvis is connected to your spine by the sacrum. It's a triangular bone that sits between the two hip bones of your pelvis. So this is your sacrum in here. These are your pelvic bones, and these are your leg bones, and they're hanging inside this joint right here. They hang on in your pelvis. Leg bones are just sort of hanging there. Leg bones and arm bones are a lot alike, but leg bones are thicker and longer than arm bones. These are leg bones. Look at this nice joint up here. That's a ball joint. We have a femur, tibia, and fibula. And then these are all phalanges down here. Leg bones and arm bones, a lot alike, but in fact, the longest and heaviest and strongest bone in your entire body is in your leg. You know the name of that? Well, which one there is the longest and the thickest and the strongest? It's your femur. Your femur is connected to your pelvis and extends all the way down to your knee. If you look at the picture, you'll see two bones in the lower part of your leg. The larger of the two, the one in the front, is called the tibia or shin bone. And the thinner bone behind it is called the fibula. Both the tibia and the fibula connect to the knee and the ankle. That's a lot of information, and I suspect some of you are wondering how all these different bones are connected. Sure, they're all attached to hangers, the scapula and the pelvis, but how? Are they glued in place? Are you glued in place? No. So let's find out, how are all our bones connected? The point where two bones meet is called a joint. Let me repeat that because it's important. The point where two bones meet is called a joint. Without joints, your body would not be able to move. There are three main types of joints in the body. You have movable joints, immovable joints, and partially movable joints, which is like partly movable. So joints that can move, joints that cannot move, those would be immovable. Ooh, there's another really good prefix that means not. Immovable and partially movable. Some joints can move, some joints can't, and some move just a little bit. So we're going to take a look at some of these. The most movable joints in your body are called ball and socket joints. Make a fist with one hand, then wrap the fingers of your other hand around it. You can move the fist around easily inside your other hand, can't you? This type of joint is found in both your hips and your shoulders. Ball and socket joints allow you to swing your arms and your legs in a full circle. Look back here. You can easily see the ball at the end of your femur, and it goes into this socket right here in your pelvis. It can slide around easily. You can move your leg in many different directions. Okay? That's a ball and socket joint. The most movable joints in your body. Other movable joints are called hinge joints. When you think of a hinge, what do you think of? I think of a door or a cabinet. And that part that connects the wall to the door is called the hinge. It's usually made of metal. And does a hinge move in a circle, a complete circle? No, it really just swings in one direction. You can open it, you can close it, but my door does not swing in a whole circle. So there are lots of hinge joints in your body. They only move back and forth instead of turning in a full circle. Your knees are hinge joints. Your elbows are hinge joints. Your ankles are hinge joints. You can move them a little bit. Knuckles, they all have hinge joints. In fact, your knee joint connecting your femur to your tibia and fibula is the biggest and strongest joint in your whole body. And it's not a ball and socket joint. The biggest and strongest joint in your whole body is a hinge joint. It lets your body bend at the knees, stand up and bend at the knees. Imagine you trying to walk without hinge joints. What if you couldn't bend at the knees? Well, if you've ever had surgery on your knee and had a cast that went from your femur down to your tibia and fibula to keep your knee from bending so it could heal, you would know it's very difficult to walk. You probably had crutches or maybe even a wheelchair because it's very difficult to walk without bending your knees. Some joints permit no movement at all. They are called immovable. Im means unable to, not movable. Can you think of any axial bones that fit that description? Your skull is made up of bones that are locked firmly in place. They do not allow movement where the bones come together. They are immovable joints. Third type of joint in the body is the partially movable kind. The ones that move only a little bit, but not nearly as much as a ball and socket or a hinge joint. Can you think of any example of a partially movable joint? Do you remember when you took deep breaths and watched your chest move in and out? The joints where your ribs are joined to your breastbone are a good example of partially movable joints. They do move a little, but they're not moving a lot. Certainly not like a hinge or a ball and socket. This is an important slide. Take a look at this one. Remember cartilage, that soft tissue found in your nose and your backbone and between your vertebrae? Cartilage is found at the ends of bones where they connect with joints as well. This smooth, elastic tissue serves an important purpose. Try rubbing your palms together. Do you feel the heat? If bones and joints rubbed back and forth together like this with nothing in between them, your bones would wear out. Instead, a smooth, slippery coating of cartilage covers the bones where they meet joints, protecting them and helping them to last longer. Makes me think of a riddle. What are tough straps of strong elastic tissue that bind bones together? Our name has 3 syllables and comes from the word that means to tie. What are we? Thick cords called ligaments. Cartilage is slippery, prevents your bones from rubbing together, but there's another connective tissue that acts like straps or string or rubber bands that wrap around your joints to actually hold your bones together. These thick cords are ligaments. So ligaments tie your bones together and hold them together. Cartilage helps to let your bones slip by one another in a joint. Some ligaments are round like rope. Others are flat like ribbons, but they are all extremely stretchy. Has anyone ever told you that you are double jointed? Well, double-jointed people can bend their fingers back farther than other people, but they don't really have extra joints. Their ligaments holding their joints together just stretch farther than normal. So if you're double-jointed, you are stretchy ligamented. You have stretchy ligaments. Raise your hand if you have stretchy ligaments. Extra stretchy ligaments are double jointed people. I do not have extra stretchy ligaments. Ligaments and other protective tissue help prevent injuries to your bones. Nevertheless, sometimes bones do get injured and sometimes they wear out. Humans are very active. You walk, you run, you jump, you play, and you put stress on your bones. So what happens if you break a leg, sprain an ankle, or dislocate a joint? Often you need to see a doctor, and sometimes your doctor will recommend an X-ray. Now that you have lots of information about the skeletal system, both the axial bones and the appendicular bones, let's take a look at this thing that we call X-rays. How many of you have had an X-ray? Raise your hand. I'll bet a lot of you have. Okay, these are X-rays of different skeletal parts of your body. How interesting. These X-rays of various parts of the human body. An X-ray is an invisible light that can travel through the soft tissue of your body, like your muscles and your skin, but not through the hard bones. After an X-ray passes through you, a picture is recorded on photographic film. Soft tissues appear black on the film because the X-ray passed right through them. But wherever the X-ray is blocked by bone, white areas appear on the picture. That allows doctors to find breaks more easily. X-rays were invented as a medical tool just over 100 years ago. Here's Ricardo again, our narrator. Thank you, Ricardo. Next time, we're going to discuss another important body system. Can you look on his t-shirt and guess which one? You're right. So let's go over what we learned today. Appendicular bones are the bones that hang from your axial bones. So you have femur, tibia, fibula, bones in the leg. What's an appendage? An appendage is something that is attached to or hangs from something larger. So your fingers are appendages of your arms. Your arms are appendages of the trunk of your body, your axial part of your body. What are appendages on the human body, and why are they called appendages? Well, your arms and legs are appendages, and they hang on the larger section of your body. What is a point where two bones meet? That is called a joint. And what are the three main types of joints? You have movable joints, immovable joints, and partially movable joints. And some examples of those are movable joints are ball and socket joints and hinge joints. They help different parts of the body, such as your knees and shoulders, bend easily. There are immovable joints that lock bones in place, like the bones of the skull, really make a hard helmet for that important part of your brain and your senses, your eyes and your ears. And then you have partially movable joints, such as your rib cage, which allows for a little bit of movement, but not so much movement as a movable joint. Why is cartilage important to the joints? Cartilage is smooth and slippery, and it covers the bones at the point of a joint to protect them, and it helps them to last longer. If there was no cartilage at the joints, what would happen? Well, your bones would become worn down more quickly and easily. Would ligaments still be able to do their job if the tissues that they were made of was not stretchy and connective? Remember, ligaments are the stretchy rubber band, super rubber band, or ribbon types of tissues that hold one bone next to another. How does an X-ray work? Well, invisible light from an X-ray passes through tissue but not bone. The image that the invisible light creates is recorded on a film, and that allows a doctor to check for many issues related to the bones. Why do you think it's more common to break an appendicular bone than an axial bone? Well, an appendicular bone is more vulnerable because they're more exposed. They're used more often to move about and to play and to stretch and all that kind of thing. If your body were a tree, which parts of the tree would be your appendicular bones, and which parts would be your axial bones? Think about that.